Welcome to Understanding Why, with math concepts explained with models and multiple methods. In this video, we're going to multiply fractions by a whole number and multiply fractions by fractions. So if you think way back to the beginning of multiplication, 2 times 3 meant two groups of 3. And there's that magic word of. So the multiplication sign could be replaced with the word of. So 2 groups of 3. Well, here is 1 group of 3, and here would be 2 groups of 3. So multiplication is really repeated addition. So 3 plus 3 is going to give me 6. 2 times 3 will give me 6. The same concept can be applied to multiplying a whole number times a fraction. So if I looked at 3 times 1/4, I would have 3 groups. So here are my 3 groups. And in each group, I would have 1/4. So I'm going to cut each group into fourths. And then each group is going to have 1/4 shaded in. So here's my model of 3 groups, 1, 2, 3, of 1/4. So if I wanted to count them up, this would be 1/4, 2/4, and 3/4. So 3 groups of 1/4 could be 1/4, there's 1 group, plus 1/4, there's 2 groups, plus 1/4, there's 3 groups, and that will give me 3/4. Now, to do this mathematically, I could say 3 over 1 times 1/4. And the reason I say 3 over 1 is because I have 3 whole groups. So each group is only 1 part. So now I would just multiply my numerators. So 3 times 1 will give me 3. I will multiply my denominators. So 4 times 1 will give me 4 to get my answer of 3/4. Now, if I want to multiply two fractions, if I want to do 1/5 times 2/3, again, I could multiply my numerators. So 1 times 2 is going to give me 2. And I can multiply my denominators. 5 times 3 is going to give me 15. Now, if I wanted to see a model of this, I want 1/5 of 2/3. So the first thing I'm going to do is I'm going to draw 2/3. So here is my thirds, and here's 1/3, and then here is 2/3. Okay? Now I want 1/5 of that. So I'm going to cut my model into fifths going the other direction. We're going to pretend that those are a little bit more even than they are. So here, if looking this way, these were my thirds going vertically, and then these are my fifths going horizontally. So I want 1/5, which means I want 1 of these groups. So there's my model, and I find my answer by counting how many of these spaces have both of them overlapped. So now I have 2 that have them overlapped, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I essentially made an array, 3 by 5, which is my common denominator of 15.